So today we are going to start our lecture number 17, that is speed control of three-phase induction motor by pole changing method. Still now we have covered speed control by variable frequency technique and stator voltage control, and this is the last method, which is pole changing method, by which we can control the speed from stator side. So in pole changing method, we basically change the number of poles. Now if we recall our basic equation, that is synchronous speed ns equals to 120 f by p. So if I put here, it is rotor speed equals to 120 f by p into 1 by s. So from here we can see, we have already seen by changing the frequency how the speed can be controlled. We have seen that changing the voltage, how the speed can be controlled. So now we are going to see by changing the number of pole how speed can be controlled. Now by this pole changing method of speed control, this pole changing method can be achieved by two way, or rather we can say in three way. One is known as multiple stator winding, second is method of consequent pole, and the third method is pole amplitude modulation. And this pole amplitude modulation of speed control are suitable for cage motor only, because cage rotor automatically develop number of poles equal to the poles of the stator winding, whereas consequent pole technique is also applicable for cage rotor, right? Now first method is multiple stator winding. Now in multiple stator winding, what we do, we keep two different arrangement of winding for different pole number inside the stator, and among these two winding, one winding is energized at a time. Suppose a motor has two winding, one for 6 pole and 4 pole for 50 Hz supply. The synchronous speed will be, for 6 pole it will be 1000, because 120 f by p, p is 6, it is 1000, and for 4 pole it is 1500 rpm. Now if the full load slip is 5%, in this case the speed will be n equals to, for 1000 synchronous speed it will be 950. If we put this, if we put in this equation, we will get, and for 1500 rpm the speed will be around 1460 1480 rpm respectively. Now this method has certain disadvantage. What is that? Now inside the stator we have to keep two different arrangement for two different setup of poles. Now the stator size will also increase, because we have to accommodate two different arrangement, so it is costly and it is less efficient. So this method is only used for special purpose, where for a particular case two different speed is required. Now the next method is pole changing method. Now by changing the pole, we can change the speed of the motor, as we have discussed. Now in this pole changing method, the stator winding are combined, or rather owned, for different number of poles, which results in two speed motor, and basically it is in the 2:1 ratio. Now two independent winding on the stator is being designed to give different number of poles in the ratio of 2:1 also can give 4 different synchronous speed. Now this arrangement, here the arrangement has been shown for 2:1 ratio, means this is for 8 pole and this is for 4 pole. So 4:8, that is 2:1 ratio. Now this same stator winding, can be arranged in the ratio of 3:2 or 1.5:2. So 4-speed induction motor can be obtained. But here in our discussion, we only discuss the 2:1 ratio. Now, before we go further into the details of pole changing method, I will give some brief idea about how a north pole and south pole is produced. So this is south pole. So if we extend this arrow, so it is, the rotation is clockwise, whereas for N it is anti-clockwise. So current is out from here, so this is minus, this is plus, whereas current is going inside, so this is plus, so minus. So this is cross and this is dot. So when the current is downward, a north pole is produced, and when is current is upward, that is going inside, then a south pole is producing, right? Now if we see this stator winding arrangement, now what we see, now from here the current A is entering and it is going in the winding number, coil number 3, and it is returning through B, and for coil number 2 and 4 it is entering through C, going to coil number 4 and returning through D. So current is going upward, so it is cross current, and here the direction is downwards, so dot current. So here the direction is downward, here also the direction is downward. So we have seen just in our this picture is current is downward, a north pole is produced. So here the north pole is produced. Similarly here the current is upward and here is upward. So a south pole is produced, and similar fashion north pole, south pole, north pole, south pole, consequent pole has been developed. And we can see that it is 1, 2, 3, 4, 5, 6, 7, 8. So 8 pole has been configured by arranging the stator core coil, and here it is shown for only single phase, Now, so through A is entering and its 3 is entering and going out through B. So if we rearrange this one, so we can show in this same way, right? Note that the coil 1 and 3 in series, because the same direction of current is flowing through this coil, whereas 2 and 4 are in series. So two distinct coil is formed. Now if the terminal B and C are connected as shown in this figure, 4 coil become in series. 4 coil become in series. 1, 3, 2, 4 all are becoming in series, and 8 pole is produced, right? The same number of poles produced again if the terminal A is connected to C. So here also you can see from A the current is entering and from B is exiting, and from C current is entering and D is exiting. But here the connection is 1, 3 in parallel with 2, 4. So by series and parallel connection, we can make the number of pole 8. Now, if we change any of the two coil connection, means we can change 1 and 1, 3, or we can change 2 and 4. Means here the direction of 2 or 4 is, it is going upward and then downward, and upward and downward. We will change this 2 or 4 reverse, means it will be downward, it will be upward. So we have done this. So it will be downward and upward, downward and upward. So through A the current is entering, through coil number 3 going in and exiting through B. Whereas in case of this time, it is going through D and exiting through C. Now 1 and 3 the current is entering. So now B and D is shorted. So this is the series connection. Now if we look, so current is upward and here current is downward. So this current is cross current and this current is dot. Again this is downward, so this is also dot. Upward cross, downward dot, dot, cross. So the interesting thing is that, so this is downward, north pole, right? North pole. So what happened? So as these two become same dot current, so now number of pole is reduced half. That is why it is 2:1 ratio. So here the current is upward, current is the south pole, and in this fashion we can see only the 4 number of pole has been produced. So we can do it by series connection, and as I have mentioned, in case of 8 pole we can done it by parallel connection. So 4 pole is produced. So we can say that if the current in the two coils flows from A to B, and from C to D, 8 pole is produced, A to B and C to D. Whereas if the current of the two circuit flows from A to B and reverse D to C, then 4 pole is producing. So by this consequent pole techniques, we can change the number of poles and we can in the same time vary the speed of the induction motor. Now interesting fact is that two things we have to remember. First of all, this is applicable for squirrel cage induction motor, because in squirrel cage induction motor the poles of rotating magnetic field is producing, similar pole is producing in the rotor. So we don't have to worried about the number of poles in rotor. Whereas in case of slip ring induction motor, the rotor winding design has to change so that the same number of pole is produced as on the stator. So it is applicable for particularly in squirrel cage induction motor, because in case of squirrel cage induction motor, the rotor poles follow the stator pole. So as the stator pole will change from 4 to 8 or 8 to 4, it automatically the rotor poles will get changed. Now another thing is that according to here, as the pole is changing in discrete values of even integer. So here this continuous smooth speed control is not possible. So here in step we can get the variation of the speed. Now this is we have shown for single phase, and this logic is we can apply for all the 3 phases for production of 8 pole and 6 pole. So the same logic is here implemented. So this is high speed 6 pole and this is low speed, and this is the variation of torque speed characteristics. So you can say here it is the speed changing is not continuous, discrete in step for 6 pole here, for 12 pole here. Now this is for constant torque control and this is for constant power control, and this is for variable torque control. Now what is constant torque control, what is constant power control, what is variable torque control? We have mentioned in pole changing method. We have also mentioned this in when we have discussed V by F control of speed control. So we will discuss this fundamental of constant torque and constant power in our next lecture. So this is all about of speed control of 3-phase induction motor by pole changing method by multiple stator winding and method of consequent pole. And pole amplitude modulation technique we are not going to discuss here. We will discuss it later. So in our next class we will study the speed control from rotor side, that is by changing the rotor resistance and the slip power recovery scheme. Thank you.